Welcome to the Rim Break Rodeo. We hope this video helps.
You start by preparing a reproducible environment. Create a virtualenv and install Python 3. 10+, then add NumPy, SciPy, Librosa, Sound Device, Torch, and Transformers. Once done, configure your microphone input and confirm the sample rate. Use 44, 100 Hz for full band audio or 16, 000 Hz for speech models. You now capture raw audio chunks with Sound Device, normalize levels, and store short WAV buffers. Make sure to monitor latency and dropouts. This initial capture loop is the foundation for every later step. You pick a practical model next. Use a pre-trained transformer ASR or a lightweight RNN/CNN hybrid for on-device needs. Once chosen, preprocess audio into framed spectrograms or MFCC, then apply augmentation. Add background noise, vary pitch and speed to improve robustness. You fine-tune with CTC or sequence-to-sequence loss, batching by similar length, and using gradient accumulation when necessary. Make sure to monitor WER and loss curves, and validate on a held-out set to avoid overfitting before deployment. You finalize by integrating the model for live use. Implement voice activity detection, buffer frames, and stream inference with low-latency batching. Once done, optimize runtime, apply quantization, torch script, or ONGS export, and reduce unnecessary copies to cut latency. Make sure to implement confidence thresholds and language model rescoring for better accuracy. If results degrade, check sample rate mismatches, incorrect normalization, or gaps in augmentation. Retrain with diverse noise types and reevaluate the preprocessing pipeline to resolve.
Thanks for watching. Consider subscribing if we helped you.